Okay, today we're going to talk about our second tab in the foldable, which is Unit 14, Effects on Functions. We're going to talk about horizontal shifts. Yesterday we talked about vertical shifts, which means a graph is moved up or down, exactly how it looks. Today we're going to talk about horizontal shifts, which means a graph is moved left or right with exactly how it looks. In general, an equation is affected when you have these letters in certain spots. So I went ahead and I put an equation up here. Yesterday we talked about if you add or subtract a number at the end of an equation right there. Okay, it's all the way at the end. Notice how it's not in the parentheses. But if you do that, you get a vertical shift. And this is what we talked about yesterday. And if the number was positive, okay, we knew that went up. Okay, it shifted the graph up. If it was negative, it moved the graph down. Okay, today we're going to talk about a horizontal shift. And that's when you have a number in the parentheses and you have that number by x. More specifically, you're adding or subtracting from x. So it's where that c is. So when you add or subtract a number from x, it's going to create a horizontal shift, which means the graph will move left or right. So we write horizontal shift. Okay, we've kind of done these before with quadratics. Okay, when you went to find the vertex, remember how you kept the number on the inside of the parentheses, you took the opposite of it, wrote it down for the vertex, and the number at the end you wrote the same. This works the same way, so it's kind of weird. If you are adding, a number next to x, it's going to actually move it to the left. If you are subtracting, it will actually shift the graph to the right. Okay, so we're going to look at a few graphs and talk about them. All right, so let's go ahead and talk about it. So first of all, this first graph, f of x equals x squared, we know that's a quadratic function. So let's get a picture of it. It should make a u. Okay, notice over here I added 4, but I didn't add it on the end. I actually put it inside parentheses. Okay, the function's still squared, but I added a number inside parentheses. Okay, when I did that, it created a horizontal shift, and it should be the opposite of what you're doing. So if you're adding 4, that should move the graph to the left 4. So if you look at the vertex here, that vertex should be moved 1, 2, 3, 4, and the graph should be redrawn. Okay, the graph won't change, but it'll be redrawn. So let's see what happens. Okay, the whole graph isn't over here drawn. Let me complete the rest of it. But notice how the graph moved to the left 4 places. Okay, when you added 4 in parentheses next to x. Okay, our next equation, f of x equals 3x, we know that is an equation of a line. So there's the line. Notice again how you still have the 3 there, but you did something in parentheses. You subtracted 3. Okay, it's not all the way at the end of the function, it's in parentheses. So what this should do is it should move the graph to the right 3 places because you subtracted in the parentheses. So again, here's my intercept. Okay, if I look at it, if I move it to the right 1, 2, 3 places and I redraw the line, okay, that's what the new graph should look like. So let's take a look if that's right. It is. And so again, when you subtracted 3 directly from x, it shifted it to the right 3 places on that. Okay, our last graph on here is an absolute value graph. We know that should make a V, so let's pull it up. And again, over here, they wrote it a little bit differently. Notice how they have a +2, but again, it's inside the parentheses, which always creates a horizontal shift. Since you're adding 2, it should be moving the graph to the left 2 places. So if what I want to call a vertex is right there, 1, 2 to the left, okay, it should be redrawn and look like that. So let's check. Okay, so yep, move to the left 2 places. Okay, in general though, if the number is positive, you move to the left. Okay, if the number inside the parentheses next to x, if you're subtracting, that means it's negative, you move to the right. All right, let's go ahead and fill in these tables just like we did before. Notice how you had the +3 at the end of all of them. Okay, here, here, here. So that never changes, so there's no vertical shift. The thing that happens is inside the parentheses, in this case it's the absolute value brackets. So all these are going to be creating horizontal shifts, but I'm just going to fill in the table exactly like I did yesterday. So I'll go through the first table and just talk through it because it should be easy to fill in even without a calculator. So if I'm putting in -2 for x in the first table, the absolute value of -2 is +2. +2 plus 3 ends up being 5. When I fill in -1 there, the absolute value of -1 is +1. +1 plus 3 is 4. The absolute value of 0, 0, 0 plus 3 is 3. The absolute value of 1 is 1, 1 plus 3 is 4, and the absolute value of 2 is 2, and 2 plus 3 is 5. Go ahead and see if you can fill in the other ones in the other tables, and I'll go ahead and pull it up and put the answers on without going through it. Okay, I went ahead and filled in the other numbers. Looks like one of them didn't show up. There we go. Okay, so I went ahead and filled those in so you can check. But the main thing to notice, when I went from this first graph to the second one, from f of x to g of x, the only thing that changed is this minus 2. So we went ahead and talked about when you subtract a number from x, it creates a horizontal shift. In this case, it would shift to the right 2 places. Okay, it would shift to the right 2 places. So notice the 5, 4, 3, okay, that's here, happened later 2 spots down. Okay, the pattern started again later 2 spots down. Okay, if you go to the last one, okay, what changed from the first graph f of x to the last graph h of x, okay, is that plus 1. Okay, that means you had a shift to the left 1 place. So if you notice, kind of the same thing happened on here. Okay, if I shift it to the left 1 place, everything should have happened earlier, okay, earlier by 1 spot. So let me see if I can mark that on here. So let's look for the pattern. So I see a 3, 4, 5, and I see a 3, 4, 5 over here. Notice how that happened 1 spot earlier because the graph actually moved to the left. So everything happened 1 spot earlier on that. Let's take a look at a few questions now at the bottom. So I'm going to put these up here if you want to write them down. It says, how can the graph of f of x be changed to get the graph of g of x? So let's go up. So f of x is the first one, g of x is the second one. So from here to here. If you notice, the only thing that changed is right here, so we already talked about it. That would create a horizontal shift to the right 2 places, okay, because you were subtracting 2. So that graph would be moved to the right 2 places, and nothing else changed on it. So horizontal shift. Okay, right 2. Okay, the second question up here. How can the graph of f of x be changed, to get the graph of h of x? I'm going f of x to h of x. So let's go back up here real quick. So now I'm going from the first graph to the last graph. So this one to this one. Did something weird there. Hold on. There we go. F of x to h of x. What's it doing? There we go. F of x to h of x. Sorry about that. All right. The plus 3 stayed the same at the end, so I'm going to put a dot by it. So that didn't change. The only thing that changed is right here. Okay, so again, from the first graph to the last graph, I have a plus 1 in the parentheses, so that should mean that it moved to the left 1 place. So I'm going to go down, horizontal shift to the left 1 place. So left 1. And the third question, how can the graph of g of x be changed to get the graph of h of x? So this time we're going g of x to h of x. So make sure you read as you go through the questions today. So g of x to h of x. All right, so again, the last thing didn't change. So there's no vertical shift. The middle change, I went from -2 to +1. So if you go from -2 to +1, you should say, oh, I added 3. To get from -2 to +1, I added 3. Since you added 3 in the brackets, that should be a shift to the left 3. Remember, adding moves it to the left. So from g of x to h of x, I shifted to the left 3. Okay, so that one's a little bit tricky. Okay, so horizontal shift to the left 3. Okay, and the last one, suppose I wanted to create a new graph r of x in which I shifted h of x to the right 10 units. Write an equation for r of x. So let's go back up to the top. So I wanted to write a new equation where I shifted h of x, which is right here, to the left. I think it said to the left. I'll make sure again real quick. Oh, to the right, sorry. To the right 10 places. So to shift something to the right, we know we are subtracting. You're doing the opposite. You're subtracting 10. Okay, so my equation up there was originally down here. Okay, x plus 1 was on the inside. If I want to shift it to the right, I'm going to subtract 10 on the inside. Okay, so it's going to look like that. Okay, my new equation. Okay, so x plus 1 minus 10 is actually x minus 9. Okay, that's what it would have to go in the inside of it. X minus 9. Okay, so let's go back down here. Okay, so that new equation that we were just talking about, r of x would actually equal x plus 9. And then, of course, you had the plus 3 okay, at the end okay, for that. Another way to write it okay, that they may ask, we talked about it yesterday, all you were doing is taking the h of x function and you were subtracting 10 in the parentheses from x to move it to the right. Okay, so that's another way that you would write it. I think the last question on Math Excel has you write it like that. And I messed up real quick. Minus 9 is what I had written at the top. You go back. Some of you are like, plus 9, you said minus 9. Yeah, it should have been minus 9 that we